Hey everybody, thanks for joining me for another lesson. I hope you're not getting too tired of my voice. I think this is Notes 22 and we're talking about higher order derivatives today. That means taking a derivative of a derivative, maybe a derivative of a derivative of a derivative. You can do it as many times as you want. So the first thing I'm going to do is talk about notation and then we'll do some examples. So of course we have our two kinds of notation. We have our function notation and we have our Leibniz notation. And we've already seen that when we take a derivative of f of x, the notation is f prime of x. So we would now call that the first derivative. And if we want to find the second derivative, then we add in another prime, so it's a double prime. F double prime of x is the second derivative. We find that by taking the derivative of the first derivative. And the third derivative is f triple prime. Now beyond that, it would get kind of wide if you kept just adding more and more primes, so the notation usually changes a little bit. We put a little 4 here for the fourth derivative, and I think sometimes it's put in parentheses. Maybe you don't always see it in parentheses. So then for the nth derivative, we'll just write it like that. Okay, when it comes to the Leibniz notation, we've seen that the derivative of y is dy dx, assuming here that your variable is x. Of course, if your variable is something else like t, then you would have dy dt. So we just make that adjustment. So now we're calling that the first derivative. And the second derivative looks like this. D squared y dx squared. That's how we say it. Technically, we're not squaring anything. That's just the way you pronounce it, and this is how it looks. And it just means the second derivative. So we can continue like that for the third derivative, the fourth derivative, and so on. So we can just maintain that kind of notation for the nth derivative as well. Okay, so let's look at some examples. Here I have the kind of notation where we're sort of fusing the two. So it's y prime, y double prime, y triple prime. And our function y is y equals square root x, which I would like to rewrite as x to the 1/2. So let's find y prime, and then after that we can find y double prime, and then after that we can find y triple prime. So I'm going to use the power rule, bring down the old power, subtract 1 from it to get the new power. Now let's take that and find y double prime. So we're using the power rule again and multiplying by 1/2, the constant. So we have 1/2 times, now we bring down the old power and we subtract 1 from the old power to get the new power. And what we're going to do is simplify this and write it back in its radical form for our final answer. So we have y double prime is negative 1/4 times 1 over the square root of x cubed. Now I'm going to go ahead and write that as a single fraction. So y double prime is negative 1 over 4 square root x cubed. Now you could also pull an x out of that radical, so you'd have x square root x instead of the square root of x cubed, but I'm not going to worry about that right now. So that's one of our answers. And now to find the derivative of that for the third derivative, I'm going to go back and use the power notation form. I'm going to rewrite it as negative 1/4 x to the negative 3/2. And for its derivative then, bring down the negative 3/2 and multiply it by negative 1/4, and then subtract 1 from your power to get your new power. So that's the same as 3/8 times 1 over the square root of x to the 5th. So writing that as a single fraction, we have y triple prime equals 3 over 8 times the square root of x to the 5th. And just like before, if we were going to simplify the radical, we can write 3 over 8 times x squared times the square root of x. Okay, let's take a look at another one. So I guess I was just kind of lazy, and the easiest thing for me to type into the computer is y double prime instead of f double prime of x, or instead of d squared y dx squared. So once again, I used the y double prime and y triple prime notation, and here's our function. Notice that it's a product. Now we're going to stop and think before we work. We can use the product rule to find the first derivative. No big deal, it's going to be pretty easy. Thing is, after that, we need to find the derivative again, and the derivative again, and there's a chance that we're going to end up using the product rule multiple times and more times as we go. So maybe it would pay off in this case just to simplify the function first before taking any derivatives. In some other case, it might not be possible to do that, or maybe it's no big deal. But what I'm going to do is I'm going to FOIL and get x to the 5th plus x to the 4th plus x squared plus x, and then take that and find the derivative, the second derivative, and the third derivative, because we won't have to use the product rule. Not that we don't like the product rule, but we're kind of lazy and we want to do whatever seems to be the least amount of work. We also want to do whatever seems to be the lowest risk of mistakes. So I feel like that would happen here. So here's the first derivative. Let's take the derivative of that, and we'll have our second derivative, 20x cubed plus 12x squared plus 2. Remember, the derivative of a constant is 0. So the derivative of 1 is 0. And now we're about to find the second or the third derivative. That's our second derivative. So when we take the derivative of 2, it's going to be 0. So the derivative of 20x cubed is 60x squared plus the derivative of 12x squared is 24x, and then the derivative of 2 is 0. Okay, if you had used the product rule, you would have answers that were equivalent to these answers. Okay, number 4. Finally, I switched notation, and also in this case, we're plugging in a number. So we're finding the fourth derivative of f at the value t equals 1. So we can't plug in the 1 until we finally get the fourth derivative. So we're just going to start by finding the first derivative. Notice I'm kind of fusing all the different notations together here. So bring down the 9, and we have 54t to the 8th. And then bring down the 5, we have minus 10t to the 4th. Don't plug in the 1 yet. Now we find the second derivative. By the way, the first derivative we could write as df dt, and the second derivative is d squared f dt squared, and that's going to be, okay, grab a calculator, 54 times 8, 432. So 432 t to the 7th minus 40 t to the 3rd. Now let's find the third derivative, which we could write as d cubed f dt cubed. And that is, bring down the 7, 3024 t to the 6th minus 120 t squared. And now we'll find the fourth derivative, which we could write as d to the 4th f dt to the 4th. So we'll multiply our 3024 by 6. We get 18,144 t to the 5th minus 240t. And finally, we're evaluating that at t equals 1. So we have 18,144 times 1 to the 5th minus 240 times 1. And that gives us 17,904. Okay, so shorter lesson today. I hope you don't mind. Sometimes we need a little bit of a break. Shorter lesson, shorter assignment from a short teacher. Thanks, everybody.